one more fun example here, and this again goes along with what we were talking about with how to use the first derivative. You'll notice a lot of these questions are the same. Where are the critical points? When am I increasing, decreasing? Find the maximum. All those kinds of things are very common questions to ask, but this is a more complicated function, and here's why. If I want the critical points, the first thing I need is a derivative, okay? But this is not a super straightforward derivative. This is going to require some product rule. Here's u and here's v. U prime then, if u is e to the x, u prime would be just e to the x. And v prime would be derivative of x squared, so that's 2x. So my derivative is going to look like this. U prime v, so that's e to the x times x squared, and then plus v prime u. I'm going to put the e to the x first, so that's u, and then here's v prime. And I want to somehow make this thing equal 0. Now, solving this is a little trickier, okay, than the ones we've been doing, because the ones we've been doing I think have been pretty straightforward from this point. What I do want you to notice is that both of these terms have an e to the x in them. So I think I'll start by factoring out the e to the x. So then I have e to the x times x squared plus 2x. And actually, x squared plus 2x could even factor further. I could make this e to the x times 2, nope, I'm sorry, not 2. X is what I meant to pull out of there. They both have an x in common, so I can make it an x, and then times an x plus 2. Okay, so I kind of did like a double parenthesis here thing, but this is really like this times this times this. It's 3 factors, and I want this thing to equal 0. Okay, so remember the goal with factoring is to take each one of these factors and set it equal to 0. So e to the x equals 0, or x equals 0, or x plus 2 equals 0, and then for each one of these we're going to solve and figure out what x would equal. Well, e to the x equals 0, I hope that's kind of jumping out at you. That is not possible, right? There's no exponent in the world that I could put here that would turn this thing into a 0. E to the x is going to have an asymptote on the x-axis because it never can equal 0. So this is not possible, okay? There are none here. This guy does not help me with any critical points, okay? But x equals 0, I mean, I already drew the arrow, but I really didn't need to. That's just one of my solutions, right? X equals 0 is a critical point. And then also x plus 2 equals 0 gives me x equals negative 2. So my critical points are really these two right here. Okay? That's where I have a potential change in direction. So now we're going to figure out how does the direction actually change as far as being increasing, decreasing, all of that. So let's take a look at a number line. And I'm going to put on here 0, and I'm going to put, oh, negative 2 is over here. I should move that 0 over some. We'll do this. Here's 0, here's negative 2. I just like to give myself a little more space. Okay, so I'm going to pick some values here, and I'm going to be careful about it because I know that what I'm plugging it into is this derivative here, and that looks a little bit complicated. So let's see, bigger than 0, I might choose a 1. And then between 0 and negative 2, maybe I'll choose a negative 1, and then here I'll choose a negative 3. And I also think sometimes it's easier to plug into like this version of the function, okay, the one that's been all factored already. Because if all I care about is whether we're positive or negative, watch how this is going to go. Well, e to the x, no matter what, even if I put a negative number in there, this is always going to be positive, right? So even if I put a negative 3 in there, this thing will never turn negative. So this has to be positive. Now, if I'm plugging in negative 3, this is going to be negative. And then negative 3 plus 2, that's another negative value, right? So if I'm multiplying positive times negative, I'm expecting that end result to come out to be positive, okay? because I'm putting I'm putting a negative number in here, and then multiplying. Okay? If it's easier to look at this version of the formula, negative 3 squared is 9, and then 2 times negative 3 is negative 6, so 9 plus 6, this is still going to come out to be a positive 3. Okay, and then you're multiplying by e to the x, which is always positive. So now let's try it with negative 1. Okay, once again, e to the x, always going to be positive. Always, always, always. Doesn't matter what I put in there, it's always going to come out positive. If I'm plugging in a negative 1, this is going to be negative. And then negative 1 plus 2, that's a positive 1, so this will be a positive value. And so if I'm multiplying positive times positive, that is going to come out negative. And let's try one more. Let's try it with a 0. And actually, 0 might be the easiest one of all. If you plug 0, well, I guess it's going to be, I'm sorry, I'm not plugging in 0. I'm plugging in 1. I was looking at the wrong number here. Okay, if I'm plugging in 1, I plug 1 in here, I get e to the first power, which is 1, which is positive. I put 1 in here, which is positive. Okay, and then 1 plus 2 is 3, which is also positive. So if I'm doing positive times positive times positive, this is all going to be positive. Okay, so I can say that I am increasing on the following intervals. Remember, this is negative infinity over here. This is positive infinity. So I'm increasing from negative infinity up to negative 2. And also from 0 out to positive infinity. And I am decreasing in between negative 2 and 0. So that's going to look like this. Okay. Find the maximum value on this interval. That's where we're going to use the candidates test. So I'm going to set up my table. And this is anytime I'm trying to find a max or a min on a closed interval like this. And I know I'm going to check negative 3 and 2, because those are my endpoints. But then in between, I'm also going to throw in my critical points, as long as they fall on this interval. If you have a critical point that's like, I don't know, a negative 5, and it's not even on that interval, we're not going to test it, because we don't need it. It's not on the interval. But I do have a negative 2, and I do have a 0. And remember, this is really looking at the original f of x function. So this guy up here, e to the x times x squared. Okay. So if I have e to the x times x squared and I plug in a negative 3, well, negative 3 squared is 9. So this is going to give me, I'm just going to write it for now, is 9 divided by e to the third power. Okay? Because that negative exponent is going to put the e on the bottom. If I put a negative 2 in here, negative 2 squared is 4, so I'm going to get 4 divided by e squared. If I put a 0 in here, well, 0 squared is 0, and so it doesn't matter even what this is, because if I multiply by 0, this value is just going to be 0. And then if I put a 2 in here, this will be a 4, and then 4e squared. That's what this value will be. So the question is, which one of these values is the largest? Okay. Well, I want you to recognize that both of these are going to be something smaller than 1, right? Because e cubed, e cubed is going to be bigger than 9. E squared is going to be bigger than 4. Okay. So these fractions are something very, very tiny. If I'm dividing by e to some power, those are going to be small. 0 is pretty small. But 4e squared, that's going to be bigger than everything else, right? Because that's all positive values. You're squaring e. And so this value right here is my max value. So I can do that without actually figuring out what these are decimal-wise or anything like that. And this should make sense because, I mean, this is actually getting larger as we're going from negative 3 to negative 2. I'm just basing that on what we're doing up here. This is all increasing. From here, I'm getting smaller, so from negative 2 to 0, my y values are getting smaller, but then from 0 on, I'm just increasing steadily. And so the real question is just, is this number bigger than these numbers back here? And it sure is. So this would be my final answer here. 4e squared is my max value.